well, more notation. So hopefully some of these you already know about from previous work at A-level, and also some you might know for GCSE. But let's write them down in our book so we're used to them. So this first symbol up here, hopefully remember when we're talking about sets, that this means is an element of. Okay, so you have something on the left and something on the right, and you're saying that that thing is an element of this set. Now, a colon in maths, generally in a statement, means such that. So when you're reading them, so it's important to, when you get this terminology or this notation in a mathematical sentence, you read it in the right words. So when you see colon, just read it out loud as such that. Z. Do you know what Z means? Z is the set of integers. So that is just shorthand for all the integers, 1, 2, -5, -4, whatever, the set of integers we represent with the letter Z. And it is that fancy kind of Z. It looks, if you want a hint, so you just draw one line like that, draw the other line like that, and that's basically it. The reason why it's a Z and not an I is basically, if I can remember, I think it's because the German letter for integer begins with a Z, and that's why we decided to use it, because I don't know, the guy who decided on that notation was German, I guess. So next one, so that Q, again, this one denotes the set of rational numbers. So the best way to think of these is just that they're not rational. The rational numbers basically means you can write them as something over, so one integer over another integer. So something like, for example, 7.2, that is something you could represent as 36 over 5. But, for example, pi, you can't represent that as a fraction, so that is irrational. Same as, for example, the square root of 2, that is irrational, so we would say the square root of 2 is not a set of the rational numbers. Okay, so those rational numbers denotes the set of real numbers. That basically means everything that's on a number line. Okay, so anything that's on a number line, so any rational numbers, any irrational numbers, they're all on that number line, and they are called the real numbers. There are other ones, there are imaginary numbers, but we don't have to worry about that. And finally, R plus. Okay, now that just represents the set of positive real numbers. You can use that plus on other ones as well. So you could have Z plus to represent positive integers, Q plus to represent positive rational numbers. So let's just get used to some of this terminology. So here's a couple of examples. So this symbol here, well, we're saying that X is a member of the real numbers. So it's somewhere on the number line. And a second example. So try and put it into words yourself. So we're saying that Y is an integer such that, so let's just do what I said, such that it is between 0 and 10. So basically you're saying it's this set. It is 1, 2, 3, 4, 5, 6, 7, 8, 9. But obviously it takes a bit more time to write that, a bit quicker to write this if you're used to that notation. So here are some examples of mathematical mappings. So here we've got x, and the mapping, it maps onto 1 minus 3x, and x is a member of the rational numbers. Well, this would be a 1-to-1 mapping. If you like, if I wanted to draw that graph, it's very difficult because it's obviously not going to be a straight line because we've only got rational numbers. We're not talking about irrational numbers, but it would look something like Okay, it's a bit difficult to see, so something along those lines. Hopefully you get what I'm going with there. Because we're only talking about rational numbers, I'm not going to get things like pi, because it's so I'm not going to have 3.14 yet, all of that in there, that rational number. So I'm going to have gaps in that line. Yeah. So a one-to-one mapping. And for every value we're putting in of x, we're going to get one value out. No two objects are going to map to the same thing. Again, that's why I like drawing these little graphs. Excuse me. And it's also a function. Okay, because it's one-to-one. How about this one? So x, and it's being mapped, the mapping takes it to x squared plus 3, and x is a member of the real numbers. So we're going to have x squared plus 3, you should know, something like that. So it is a many to 1. Okay, because, for example, minus 2 and 2 would both take us to 7. So I've got many inputs take us to the same output. So it's many to 1 mapping. X is a member of the real numbers. So if I wanted to, that's the domain. So that's the domain. If we think about the range, what range of numbers is coming out? So this is another type of question you might get. What range of numbers is going to come out? Well, look, we're going to have a minimum point. So the range here, we could write as y. They're all going to be real numbers, and so they're all going to be real numbers, and y is going to be greater than or equal to 3, because that's the minimum point there. Is it a function? Yes, it is. It's a function. It's a many to 1. Again, using that vertical, basically anything that fulfills that vertical line test, remember. So it doesn't matter how many lines I draw down, it only crosses one point on that graph, and same up here, so they all pass the test, if you like. So we've already covered this one a little bit earlier. So we're talking about square root. Well, this is a one to many function. Okay, if I put 7 in or 8 in, well, we're told here, look, here we are. So it's a member of the positive integers. If I put a value in there, I'm going to get, so for example, 9, I get 2 values out. So it's a one to many function. If I was to draw it, again, it's integers, so it's a bit more difficult to do, but actually it would look something along these lines. So straight away, hopefully there we see that it's not a function. We know that anyway because we just said that it's a one to many. And if we think about that vertical line idea, it's not something that we're going to talk about in exams or anything, but it's just a nice thing to get our heads around it. It doesn't pass it. Those vertical lines cross the graph more than once. Okay, the range here. Well, this is a bit of a trickier one. It's not going to be all of the real numbers. It's not always going to be an integer though either, because the square root of 8 is clearly not an integer. So what we could say is that all the values that are going to come out are going to be real numbers, but only if y squared is a member of the integers. I would not worry so much about stuff like this. These are quite tricky ones to get your head around. I think most of the ones we do when there's questions like this are a little bit easier to work out. This one I'm really not going to dwell on. This is a many to many. Mapping. If I was to put 1 in there, it would map to both root 2 and minus root 2. However, for example, 1 and minus 1 would both work backwards and give you root 2. Okay, so the range of this is not quite as easy to see, to be honest. What I've done is I drew it in Desmos. which helped me out a little bit. So this is kind of it being drawn in Desmos. So the range, so remember, if you think that's kind of what is going to be hit on the y-axis, if you like, so what values. So and you'll notice that not all of it is mapped. So here is missed out. All right, so it's basically y is part of the real numbers such that y is greater than 1, or y is less than -1. Really fiddly. Do not worry too much about this. I'm giving you tons of information. It is tricky to get our head around. I wouldn't expect you to be able to do that necessarily straight away, but perhaps some of the other ones, like I said, I find it the easiest way to think about what's going on with this graph. Well, all of y is hit. Look, we're hitting all of these values up to infinity. We're hitting all of these values down here, down to negative infinity, but we are never going to hit these values here for some reason. So that's our range. Okay, so that is a lot to deal with on a Friday afternoon. I do apologise about that. I know it's a lot of writing, it's a lot of new ideas, it's a lot of new concepts. If you can have a go at the functions worksheet that's attached to that assignment, have a go at kind of questions 1 to 4, see how much you can do, use those answers that are there as well, pop onto the Google Meet if you need a hand, but try and get to grips with some of these answers and these questions.